Yes, welcome to Kaida Chemistry Channel. We are once again here for our O-level chemistry, and we are continuing with a topic that we call electrolysis. We are continuing with a topic that we are calling electrolysis. We have looked at the introductory part of this topic, and we have looked at so many concepts in electrolysis. The last time we discussed electrolysis, I was looking at, we are covering what I called lesson. We're covering what I called electrolysis lesson 4. And in that lesson 4, I covered what we call an experiment to distinguish between strong, weak, and non-electrolytes. Today we are yet to see another experiment. But before we see that experiment, I want to kickstart this lesson with a question that will help you recall or use the knowledge we covered in our previous lessons. My question is question 1. I'll go on giving you questions as the topic, as we progress during the topic. So the question 1 has part A, and it says, define the term electrolyte. And then part B, Roman 1, says, name the particles that do what? That conduct electric current. Name the particles that conduct electric current in Roman 1, aluminium, wire, Roman 2, graphite, and Roman 3, molten lead to bromide. Then part C says, give a reason or reasons why. Give a reason or reasons why Roman 1, graphite conducts. This question requires you to borrow knowledge from carbon and its compounds and relate it with electrochemistry. Graphite conducts electricity, whereas diamond does not. Yet both are allotropes of carbon. Roman 2, molten lead to bromide. Molten lead to bromide. electricity, whereas solid lead 2 bromide does not. And lastly, Roman 3, graphite is commonly used. Graphite is commonly used in electrolysis. Instead of metals like copper. So to answer this question, you need knowledge of all the previous lessons we have been having. Define the term electrolyte, name the particles that conduct electric current in aluminium wire, graphite, molten lead 2 bromide. Give a reason why graphite conducts electric current, whereas diamond does not, yet both are allotropes of carbon. Give also a reason as to why molten lead 2 bromide conducts electricity, whereas solid lead 2 bromide does not. Continue to give reasons why graphite is commonly used in electrolysis instead of metals like copper. So that is a brain check. Now, after you've seen that brain check, I want us to cover what we should cover in today's lesson, and that is the experiment to investigate. Experiment to investigate what happens during electrolysis. Experiment to investigate what happens during electrolysis. So if we are to investigate what happens during electrolysis, we shall need the following. I told you whenever I describe these experiments, try to see whether you can access a lab and do them, or find out a way by which you can try it out. What do we need for this experiment? We need the following. We need a 12 volts DC power source. $12 volts. 12 volts, remember, if we are to use battery cells, each battery cell is usually 1.5 volts. So 2 battery cells are 3 volts. Okay? And that's a pair. Pair is 3 volts. So if you need 12 volts, those are about 4 pairs. 4 pairs of battery cells. We need connecting wires, connecting electric wires. The connecting electric wires we need those, some that are black and some that are red. We need a filter paper, we shall need it, or filter papers. We need a pencil. We need water. We need red and black crocodile clips. We have often used these in physics practicals, electricity. We need red and black crocodile clips. we need potassium manganate 7 crystals, and we also need copper 2 sulfate crystals. That's all we need for this experiment to be done. How do we set up our apparatus for this experiment? I will try to draw a simple diagram for the setup of this apparatus. We shall have our 12 volts power supply. I told you the longer terminal represents the positive terminal of the battery and the shorter one represents the negative terminal. Connect our battery to a switch. That's the switch. And then this side, we shall have our black wire. This wire here is black. Black wire and is connected to the black crocodile clip. That's our black crocodile clip. Then this side we shall have our red wire. It is connected to the red crocodile clip. So I have something like that. So our black crocodile clip is going to play a role of being the cathode, negatively charged, and our red crocodile clip is going to play the role of being the anode. So it's connected to the positive terminal of the battery. Now, what else do we need? What we need is a microscope slide. I think I didn't talk about that. Microscope slides are always having a rectangular shape. This is our microscope slide. And the microscope slide has a filter paper put on top of it. This filter paper, we shall see later that it is wet. It is a wet one. So we put our filter paper on top of this, on top of the microscope slide. I hope you can draw a clearer diagram than mine. So that's our filter paper put on the surface. All right. Now, what else do we have to do? I think we have to label this. This is our 12 volts DC power supply. This is our switch. This is our black wire, black electric wire. This is our red wire. This is our red crocodile clip. Which is playing the role of the anode. This is our black crocodile clip. which is playing the role of the cathode. Now, what is the procedure? Which procedure do we do for this experiment? I've told you this is a microscope slide and this is a filter paper. So what do? We cut the filter paper to fit the surface of the microscope slide. Remember, the filter paper is circular, so you cut it from this rectangular shape so that it fits the surface of the microscope slide. Cut the filter paper to fit the surface of the microscope slide. That's what you do first. Remember, the setup is already shown here, so you can easily follow through. What you do next, you draw a line in the middle of the filter paper. Draw a line here in the middle of the filter paper. Exactly in the middle, same distance from the anode, same distance from the cathode. And then wet this filter paper with water, make it wet. Remember, electrolysis occurs if the compound we are electrolyzing in solution. So what are we saying? Next step is to draw a line in the middle of the filter paper. And wet it with water. So place the wet paper, the wet filter paper on the microscope slide. And connect it to a 12 volts DC power supply. So after putting the filter paper on here, with its water, it's already wet, a line is drawn there, connect it, make this crocodile clip touch the top of the paper and the microscope slide, and then you connect using the electric wires to the battery. Your switch there ready. And what do you do? Place, we are not going to use the electrolyte. Okay. Place a small crystal of potassium manganate 7 or potassium permanganate at the center of the line. Remember, this potassium manganate 7 is purple. So you're gonna get a crystal of it and place it in the middle here of the line. That's where your crystal is. The moment you place it there, complete the circuit by closing the switch. When you close the switch and you observe after some time, what are you going to see? Okay. Place you connect the switch, leave the setup to stand for some time. We're going to observe that the purple color is going to move towards the red crocodile clip. This clip here. Remember, potassium permanganate is purple. So we're going to see a purple color moving towards this. On the paper, moving towards this red crocodile clip. That's what you're going to notice. It's what you will observe. After some time. So what's the observation? Observation is a very simple observation. It is that purple color moves towards the red crocodile clip or to the anode. That's what happens. Now, how do we explain this really? It's an interesting experiment. What's the chemistry behind this? How do you explain this observation? We put water on the filter paper to wet it because we wanted our electrolyte to dissolve. Okay. So when potassium manganate dissolved in the water on the filter paper, it formed potassium ions and manganate 7 ions. So that's what we should note first. So when potassium manganate 7 crystal dissolved in the water on the filter paper, it ionized, or it ionizes to form potassium ions and manganate 7 ions. That can be represented by this equation. The formula of potassium permanganate or manganate 7 is that. So when you dissolve it in water, when it dissolves in the water on the filter paper, it forms potassium ions and manganate 7 ions. That's what happens first. And this happened before you completed the circuit by closing the switch. So what happens when the switch is closed? So when the switch is closed, when the switch is closed, what happens? Of course, current will flow through the circuit. Current flows through the circuit. So remember now, in solution are potassium ions and manganate 7 ions. Now the potassium ions will migrate to the cathode that's negatively charged because they are positively charged. The positive ions, the cations, migrate to the cathode, and the negative ions migrate to the anode. So that's what happens. So we shall say current flows through the circuit. Then the positively charged manganate 7, it's not manganate 7 ions that are positively charged. The positively charged potassium ions move to the cathode, because the cathode is negatively charged and the potassium ions are positively charged. They are cations, so they migrate to the cathode. That's why here we are seeing that towards the cathode there is no color. There is no color moving there. Actually, we see that side of the filter paper remaining colorless because potassium ions are not colored. So actually what happens is this. At this point, the potassium manganate ionizes to give us potassium ions, which migrate to the cathode. And then in the same solution are formed manganate ions or permanganate ions that migrate to the anode. And remember, these ones, their color is purple. You're getting me? So what happens is the negatively charged manganate 7 ions migrate to the anode. Migrate to the anode or move to the anode. And since they are purple in color, they are purple in color. That's why you see that the purple color moves to the anode. The purple color moves to the anode. While the potassium ions are colorless, hence no color moves cathode. So this experiment shows seriously what happens during electrolysis. It emphasizes that negatively charged ions, which we call the anions, migrate to the anode, whereas the positively charged ions, which we call the cations, migrate to the cathode during electrolysis. I'm going to do a small change in this experiment, and instead of potassium permanganate, I want to use another compound. The compound I want to use is now copper 2 sulfate crystals. Copper 2 sulfate crystals are blue in color. Copper 2 sulfate crystals are blue in color. So I repeat the same experiment exactly, but I'm going to use copper 2 sulfate crystals. I'll still draw a line here in the middle of the filter paper. I do the exact experiment. And now I'm going to use the blue copper 2 sulfate crystal. Copper 2 sulfate is blue. What will happen during the experiment is what I've already explained. Okay. Instead of potassium manganate 7 crystal, we are saying we are using copper 2 sulfate crystal. And when you use a copper 2 sulfate crystal, shall say that the observation actually is going to change. Observation is going to be a different case. And for this case, we shall see the blue color moved towards the which crocodile clip now. Blue color will move towards the black crocodile clip. Unlike the previous case where the purple color moved towards the red crocodile clip. So we shall have the blue color moving towards the black crocodile clip, which is playing the role as a cathode in this case. Why is that so? This is because when copper 2 sulfate crystal, the copper 2 sulfate crystal dissolved in the water in the filter paper, it ionized to form copper 2 ions and sulfate ions. Formed copper 2 ions and sulfate ions, as I'm here to show in this equation. Chemistry is so interesting. Chemistry is fun. Chemistry is indeed fun. So I have copper 2 sulfate crystal dissolving in the water of the filter paper to form an aqueous solution containing copper 2 ions and sulfate ions. Sulfate ions have a negative charge of 2. Now the copper 2 ions being positively charged do migrate to the cathode, which is negatively charged. And the sulfate ions being negatively charged migrate to the anode, which is positively charged. So that's the case in this experiment. So when the switch is closed, current flows through the circuit. The positively charged copper 2 ions in this case moved to the anode. The negatively charged sulfate ions migrate to the cathode. I mean the anode in this name. You say, I think I should change this. Sorry for this error. We are saying that correct this, have a better writer. So when we are electrolyzing copper 2 sulfate, the implication is that the positively charged copper 2 ions moved to the, remember they are positively charged, so they are cations, they move to the cathode, which is negatively charged in an electrolytic cell. And since they are blue in color, the blue color is seen moving towards the cathode or the black crocodile leaf. I think this experiment is worth noting and very interesting. Can we come to conclusions out of these experiments, these two experiments? What conclusions can we make, dear students? The first conclusion is that positive ions migrate to the cathode and negative ions migrate to the anode during electrolysis. Secondly, the other conclusion we can make is that potassium manganate. So the second conclusion is that potassium manganate 7 and copper 2 sulfate conduct electricity when dissolved in water. That's the other conclusion we can make. Potassium manganate 7 and copper 2 sulfate conduct electricity when dissolved in water. So those are the two conclusions we can make from these experiments. Those are conclusions we can make from these experiments. So I didn't complete this, but I told you that for copper 2 sulfate, we shall have copper 2 ions moving towards the black crocodile flame. Because that's the anode, which is negatively charged, and for them they are positively charged. Then the sulfate ions will move towards this side. Now, let me add something here and say that those are conclusions we make. The other thing I want us to note is that we should conclude that to the cathode, cations migrate, and to the anode, anions migrate. Anions are negatively charged ions, cations are positively charged ions, cathode is negative, anode is positive in an electrolytic cell, strictly in an electrolytic cell. Once these ions reach their destinations, the cathodes and anodes respectively, they are discharged. And when they are discharged, the cations are discharged by accepting electrons, become atoms or molecules, and the anions are discharged by losing electrons to form molecules. We shall see this in our next lesson. Subscribe to our YouTube channel for more of these lessons.